Good morning. Today we want to talk about rational expressions. And first of all, we need to know what a rational expression is. Well, that is an expression that you can write as a ratio, and it can be two polynomials. So P over Q. Now remember, you can't let that be zero. The bottom cannot be zero in a fraction, so Q cannot be equal to zero. So we're going to have to watch that a little later on. So a rational expression is a ratio of two integers. You could have 2 over 3 or negative 5 over 6. You could have a ratio of two polynomials, x plus 5 over x squared minus 6x plus 8. Those would be examples of rational expressions. So the first thing we're going to do today is we're going to evaluate rational expressions. So that just means we're going to take a value for x, or whatever your variable is, and we're going to plug it into our expression and then work it out. So if I have x equals 0, that means I'm going to have 0 plus 1 over 0 minus 3. So that gives me a 1 over negative 3, or you could write it as negative 1/3. Sometimes you like to put the negatives out front. Let's do 2. If we have 2, we're going to have 2 plus 1 over 2 minus 3, which gives me 3 over negative 1, which would reduce to negative 3. So that would also work for a rational expression. Let's skip down here and let's try this 3 and let's see what happens. If I put a 3 in, I'm going to have 3 plus 1 over 3 minus 3. Well, 3 plus 1 is 4 on top, but 3 minus 3 is 0 on the bottom. That would be undefined because we cannot have a 0 in the denominator of a fraction. All right, you can try some of those on your own in the workbook. And then now we're going to move down to restricted values. So restricted values are where we're going to find the actual numbers that are the bad numbers for the rational expression. In other words, what makes the denominator equal to 0? Let's see. Sometimes my pen goes wonky. Okay, so to find where you have denominator equal to 0, we're going to take that denominator, x plus 4, we're going to set it equal to 0, and we're going to solve for x. So I'm going to subtract 4 from both sides. So x equals negative 4. So negative 4 is the restriction on this one, because that would make that denominator a 0. If you have something, so the numerators do not matter on restrictions, it's just the denominators. On this one, I've got 3x minus 2, so let's set it equal to 0. So on this one, we're going to have to add 2 to both sides. So 3x equals 2. Divide both sides by 3. So 2/3 would be the restriction for this particular rational expression. Now, if you have something like 8 over z, well, remember, z, we just can't let z be equal to 0. There is nothing to work out on that particular one. So to find a restricted value, set the denominator, I'm going to abbreviate, equal to 0 and solve the equation. The restricted values are the answers, or you can call it solutions, either one, to that equation. So here's another one you can try where you've got x minus 5 on the bottom. So what if we get a little bit more difficult? What if we have t minus 5 over t squared minus 7t plus 12? Well, again, take your t squared minus 7t plus 12. We're going to set that equal to 0. Now, this is one where, since we have a polynomial that has a t squared, we're going to have to factor. So I need to find factors of 12 that add up to a negative 7. So I want to multiply to get me a 12. I want to add to get me a negative 7. Lost my page for there a minute. All right, so let's think about multiply to get 12. Well, I know 3 times 4 equals 12. But I could use negative 3 and negative 4. That would equal that negative 7 if I added them. So t minus 3, t minus 4. Now, since I have two parentheses, let's set each one of those equal to 0. and solve each one for x. So I'm going to add 3 on this one. So t equals 3. There's one restricted value. I'm going to add 4 on this one. So 4 is another restricted value. So when you have a squared variable, you're going to get 2 numbers for the most part that are going to be restricted values. Okay, on this one, if I have a squared plus 9 equals 0, can you factor a squared plus 9? Can't be factored because it is the sum of 2 squares, not the difference of 2 squares. So that means that the restricted values are imaginary. We'll talk more about imaginary numbers later on, but they're not real numbers because you couldn't factor that one. All right, so now let's look at this one at the bottom. Here I've got x squared minus 9. Now I can factor that one because it's the difference of 2 squares. So that's x plus 3 and x minus 3. So let's set each one of those equal to 0. Give myself a little space there. All right, so on the first one, subtract 3 from both sides. So -3 is a restricted value. On the next one, I need to add 3 to both sides. So +3 is a restricted value. So when you're writing restrictions, you see over here at this example, we're just going to put x cannot be equal to -3 and 3. You can list them, like I just listed them, or you can write them as 2 separate x is not equal to's on that page. And it's fine either way. All right, let's simplify some rational expressions. So simplifying rational expressions really is just reducing. And on these first ones, we're going to be using our exponent rules that we learned in a previous chapter. So on 35 over 75, we think of the highest number that will divide into both 35 and 75. So I know that 5 will go into both of them. 5 goes into, so I'm going to divide both of them by 5. So 35 divided by 5 is 7. 75 divided by 5, let's see, is going to be 1, 2, I believe that's going to be 15. So 7 over 15 is reduced all the way. So I think that is as far as we can take it. So you can always check yourself. If we had gotten something that would have gone further, we would have gone further. Now on this next one, you're going to use exponent rules. And remember, when we have exponents and we're dividing, we subtract exponents of the same base. So let's do the 18 and 12 first. 18 and 12 will both divide by 6. So 6 goes into 18 3 times. 6 goes into 12 2 times. And then so I'm going to have a 3 and I'm going to have a 2. Let's subtract our exponents. I've got an x squared on the top and an x to the 1 on the bottom. 2 minus 1 would be x to the 1. I don't have to put that 1, but I'm going to put it for right now. Y to the 5th over y squared. 5 minus 2 would be y cubed. 5 minus 2 is 3. 7 to the 1 over, z to the 1 over z to the 7th. 1 minus, I'm going to do this one just as a side note. 1 minus 7 is a -6. So I have a z to the -6. Now remember, we can't ever leave final answers with negative exponents. So that z needs to come to the bottom. So 3xy cubed stays on top. And I've got a 2, and that z needs to come to the bottom and be a z to the 6th on the bottom. So again, that's some exponent rules that you're going to need to remember on some of these simplifying. And you can see they did an example just like that one. So let's do one where we're not just doing exponent rules. Let's look at this next one. So if I'm simplifying a rational expression and I have a polynomial in there, then what you need to do is factor anything that can be factored, and then you can cancel matching parentheses. And what those matching parentheses are factors. So let's factor the top. In the top, remember, go through your checklist when you are factoring. look for a greatest common factor first. So I can take a 2 out of 2x minus 6. So I'm going to take a 2. I'm going to have an x minus 3 left. And then on the bottom, I've got a polynomial. Looks like it's a 3-term, and it's got a 1x squared. So I want to multiply to get that last term. I want to add to get the negative 8. So I think about numbers that multiply to get me 15. 3 times 5 is the first one I think of. Well, 3 plus 5 is a positive 8. But if I took negative 3 times negative 5, that would multiply to get me a positive 15, but it would add to get me negative 8. So that's what I'm going to use. So I'm going to have an x minus 3 and an x minus 5. Now notice I have an x minus 3 in parentheses on top and an x3 minus 3 on the bottom. Those can cancel out. I can't do anything with the 2 and the x minus 5, so I'm just going to rewrite what I have left. So 2 over x minus 5. That would be simplifying that expression. Okay, let's try another one. Now this next one, it looks like it's going to be a 4-term grouping problem because I've got 4 terms, so let's factor it. Let's do first terms, second terms. So in the first set, I've got an x squared in common. I'm going to take that out. And if I take x squared from x cubed, I have an x left plus x squared from x squared is 1. And then in the next set, looks like I can take a minus 9. So if I divide out a negative 9, I'm going to have an x plus 1 left. I'm not done with that yet. Let's just come over here and be done and keep going. So that means I'm going to have an x plus 1. That's the matching parentheses. I'm going to have an x squared minus 9. And then I'm going to simplify that just a little bit further in just a second. Let's look at the denominator. I've got x squared plus 4x plus 3. That's 3 terms with a 3. So I want to multiply to get a 3. I want to add to get a 4 in the middle. So the only way I can do that would be 3 and 1. So that means I'm going to have an x plus 3 and an x plus 1 for the denominator. X plus 3, x plus 1. Now, before I start canceling out, I need to look at that x squared plus 9 or minus 9 again. That's the difference of 2 squares. So that means I can take it a little further. So I'm going to have an x plus 1 on top. And the difference of 2 squares, the square root of 9 is 3. So that's going to be an x plus 3 and an x minus 3 over my x plus 3 and my x plus 1. So now I've broken it down as far as it'll go. I've got an x plus 1 on top and an x plus 1 on the bottom, an x plus 3 on the top and an x plus 3 on the bottom. I'm left with that x minus 3, and that would be that rational expression simplified all the way down. Now you can see another example where Alex worked that out for you. So let's move down to these ratios with a -1. Don't have a lot of these, but you need to just remember that you can switch things around in an expression as long as you're consistent. So if I've got x minus 4 and 4 minus x, those are almost the same, and I could almost cancel them out, but they're not in the same order. And so on negatives, when you have minuses, that really makes a difference. If that had been x plus 4 over 4 plus x, those are exactly the same thing. Because remember, you can move around. You've got that commutative property for addition. But with subtraction, we don't have that. So what I could do, let me just show you. I can force that 4 minus x to become an x minus 4 if I take out a -1. So that would make x minus 4 over -1, and I'm going to switch that order right there. Then those would cancel, and look what I end up with, that -1 that I pulled out to force those two to match. Okay, here's another one. X minus 3 over x plus 3, you can't do anything with that because if you change the order, you just have to leave it. This would be a neither. It's asking about ratios. I don't ask you those kinds of questions in Alex. But let's look at this one. On the top, I could take out a 5, and I would have an x minus y. On the bottom, I have a y minus x. If that y minus x were really x minus y, I could do more with it. So I'm going to make it be, I'm going to leave the top alone, 5 over x minus y. I'm going to take a negative 1 out of this bottom, and it flips the order, x minus y, like that. Now they match, and I could cancel. And I'm left with 5 over negative 1, which is negative 5. Those are probably the most difficult kind that you're going to do. And you know you can always send me questions about those. That's all I'm going to do for today so that you can kind of digest this and get to work on some homework. Y'all have a wonderful day.